Hey all, today I'm going to show you how I built my piston lava gate, but before we get into the details of how it was built, let's see exactly what it does. Now there's a few more challenges to overcome than it might seem at first, which is true of a lot of projects like this, especially when you need to control lava. Like its real-world counterpart, lava in Minecraft is a viscous liquid, so it behaves differently from water. It moves very slowly, doesn't always flow the way you might expect, and of course you can take a lot of damage if you come into contact with it. Now, if it isn't already obvious to you, this was built in creative mode using materials like endstone and bedrock, but there's no reason you couldn't build it in survival mode from more common materials. It does take a lot of redstone though, and you need slime to make the sticky pistons. Okay, let's start now with the gate open so that we can go through it. And the only real sign that there's anything unusual going on is that we've got these lava embers dripping from above. And I want you to also notice the location of these three white blocks here. They're an important part of the mechanism. The gate's controlled by two push buttons. There's one on either side so the gate can be opened or closed from inside or outside. The one on the outside is located in this little guardhouse here, so let's see what happens when we press that to close the gate. The first thing that we notice is those three white blocks I was showing you before have now moved aside, and they let the lava flow through from above. This is flowing because the pistons that hold them back have been retracted to allow the lava to flow, and it's flowing down to a chamber down below. It takes about 12 seconds for the lava to flow from the top to the time that it reaches the floor here. Now, another thing that I want you to notice is that as impressive as this looks, it's not a real barrier to somebody who wants to get in. I can walk right through lava, and in survival mode I'd take some damage doing that, but as long as I'm willing to, it doesn't really stop me from going in or outside of the gate. So it's more of a coolness factor. Another thing to notice is that the columns of lava here are staggered. And the reason that I did that was because if we put them all in a row, because of the way that lava flows, it just wouldn't flow nicely through the openings. It'd spill over, and that could make a real mess. Worse, if lava starts spilling over, it can get down into your redstone circuitry and destroy it. So we want to avoid that at all costs. Okay, so now we're on the inside of the gate, and let's see what happens if we open it again. Here's the button that controls it from the inside, and when we press that, the first thing that happens is the pistons that control the lava flow from above cut it off. And while we can't see it yet, obviously nothing has happened in the ground yet. If that had closed off now, we'd have lava flowing all over the place. It's not till it's well clear that those close off to give us a solid surface to walk across. So to recap now, when we close the gate, the opening in the ground appears right away, but when we open it, there's a long delay to allow the slowly flowing lava to clear. And this was one of the biggest challenges to overcome in order to get this project working the way that it does. Now notice the openings in the ground don't need to open up immediately when the gate's closed, as long as they open up before the lava reaches it. I've seen similar projects that address this challenge by delaying the openings to match the flow time. The problem is, even if you adjust the timing as perfectly as you possibly can, there's always some chance that lava is going to spill over and make a mess. In order to avoid this, I added a few seconds of cushion to the delay time, but the delay only occurs when the gate's being opened. So now let me show you how I did this, and hopefully in enough detail that you'll be able to build something similar. Okay, so I've opened things up a little bit so you can see what's going on behind the scenes here a little bit. And honestly, in the above ground portions of this project, there's nothing spectacular. Here we can just see three sticky pistons that either open or close the openings in the floor. And these are all just controlled by just a single lead that goes down to the control circuitry. If power is not coming through to them, then they are simply going to retract and open up the chamber below. Above us here, again, nothing that you wouldn't expect to see. Simply three sticky pistons, and lava source blocks are in behind those. And again, just one simple lead here powering all of those, and if power is lost, then the lava is going to start to flow. This tower here really doesn't serve any purpose other than to conceal the redstone lead that comes down into the control circuitry. And that's it there. This other lead here just goes over to our control button that allows us to control the circuits from the inside. It's the same lead that connects to the control button that's inside of this gatehouse here that we saw earlier, and that all feeds down into the circuitry below, which is the real heart of the system. So let me show you that next. Okay, so we're below ground, and the first thing you're going to notice is these rows of redstone repeaters, and they're all set to a full delay. This is fed by a lead that goes to the control buttons above, goes through each of the redstone repeaters in turn, and we get about a 15-second delay from that. That 15 seconds is what gives us a bit of cushions on the 12 seconds it takes for the lava to flow from top to bottom. And the reason we need 15 seconds is because that gate is just so high. If you didn't make your columns of lava quite as high, then you wouldn't need this much delay. And of course, if you made it even higher, you'd need more delay. After the delayed signal gets through, it feeds into this double inverter here. Now, if you're not familiar with what an inverter does, let me just show you here. If there is current flowing into the inverter, then there's not going to be any current flowing out. If we cut off the current, then there is current flowing out. And because we have a double inverter, we have current flowing in. That means we've got current flowing out, and vice versa. So it might seem rather pointless because we could just have a lead leading straight across, but there's actually a point to that, and understanding it is the real key to understanding how this whole project works. It's because we have a second lead that feeds into this inverter. If there is current flowing through this, then this inverter is going to be off no matter what the state of this lead is. This in turn leads up to the pistons that control the openings in the floor. So if we've got a signal coming from here, then the pistons are going to retract and the floor will be open regardless of what's going on with the delay circuit. Now, to show you why that's so important, we need to see one more thing, and that's just over here. This is a T flip-flop circuit, and the output from the circuit is what feeds into that second inverter. Now, if you're not familiar with T flip-flop circuits or what they do, we've got a video devoted specifically to the subject. You may want to check that out. But the important thing to understand is we're going to get an output to this lead every other time this circuit is triggered. And what triggers it is this lead that goes straight to the control buttons without the delay. So the effect here is that every other time we press the button, a signal's fed into here that triggers the output, that controls the openings in the ground directly. On the times when we don't get an output, every other time there's no signal flowing through here, and so the openings in the floor are controlled by this delayed signal. So that's how we get that to open up every other time, depending on whether the gate is being opened or closed. And that is the key to how this project works. You notice we have a second T flip-flop circuit here. This just controls the lava flow pistons that are in the gate above. There's no need to worry about a delay here, so this case is a little bit more simple. And that, my friends, is how this whole project works. Now, there's a couple of things to note. First of all, the two T flip-flop circuits need to be in sync so that your openings in the ground are occurring at the right time. If they're out of sync, lava is going to spill over, and because this is below ground, if there's any openings at all, it can come down and ruin all this circuitry. So it's a good thing to make sure that things are synchronizing the way that you want them before you make those lava source blocks and start working with live lava. The other thing to note, and this is less important, it is possible for these two flip-flops to get temporarily out of sync if you press the control button a second time before the delay's gone all the way through. That's actually less significant than it might sound because the system is self-correcting once that delay does come through, and I actually found it was impossible just by mashing on the control buttons to get the lava to reach the ground at a time when the floor was not opened up. So really, as it turns out, doesn't turn out to be any real safety concern. All right, so that is my project and how it works. I hope there's enough information in there for you to make use of. I hope you enjoyed the video, and until next time, have fun and keep on digging.